Hello and welcome to this week's What Were They Thinking? Amongst this week's news items, we have a record-breaking lack of vaccination for measles. The most expensive drug in the world has just been approved by the FDA. Interesting genetics when it comes to male cancer. Treating diseases in the newborn before they're even born. More Canadian alternative medicine news that has at least some silver lining to it. Debunking some of the paleo diet myths, and an alternative to rare earth magnets that can be created completely independently of any naturally occurring source. The timestamps for these and other news items can be found in the description box below. While it has been true that vaccination rates overall have fallen in some areas of the world, it's not true that this has been everywhere and for every condition. Unfortunately, some conditions are more prone to this than others, and so when certain vaccines are underutilized, we get problems. Measles is the perhaps biggest culprit for this at the moment, and that is exemplified by what's happening in America with a number of different outbreaks occurring. The report that points out that nearly 40 million children across the world have not received their measles vaccination as they should have in 2021. The report is a combined effort of the World Health Organization and the American CDC. Much of the impact is attributed to COVID-19, leading to developed and developing countries either not being able to or delaying distribution of the vaccine. The difficulty with this is that measles is practically entirely preventable through vaccinations, and so without this you have a big problem, more so when you need 95% vaccination rates to get herd immunity. 95% for herd immunity, but only 81% global vaccinations. And that's only for the first dose. It's a 2-dose regime normally, and only 71% globally have received both of the doses. The cost of vaccinating for measles is very limited. It's a relatively cheap but effective vaccine. This compares incredibly favorably to the next and newest and most expensive drug the FDA has approved. It's a drug called Hemgenix, and as the name might indicate, it is a gene therapy. It's intended to help with treating haemophilia B. This is a blood clotting disorder that reduces blood clotting. We describe it as the most expensive drug, as each dose costs $3.5 million. That's million with an M. For a single dose. The estimates for how much treating the people who have haemophilia type B is somewhere between 21 and 23 million US dollars for their life. And yes, depending on where you are in the world, this price may go up or down further. The reason this drug is so expensive is several-fold. One reason is simply that it is a very novel drug and it's based on gene therapy. These are very expensive therapies to develop. The second is that there is a relatively small base of people who will need this in the United States of America. About 8,000 males, and more males than females are affected by haemophilia B. This means that the possible opportunity for the company responsible for making it to recoup their costs is very low. When you consider the efficacy of the medication, and the fact that there is a small body of people who will be needing the medication, you can understand why the drug can be so very expensive. Still on the topic of genetics, but moving from haemophilia to cancer, there is evidence that at least amongst males, if you have cancer, there is a good chance part of your X chromosomes have been silenced. The X chromosome is effectively the female chromosome. The Y chromosome is effectively the male chromosome. Because the genes on the Y chromosome are largely male-specific, what's on the X chromosome is often used regardless of whether or not you have it on the Y chromosome as a male. In females, one version of the X chromosome will be silenced, that is, turned off, and only one of the chromosomes will be copied from at any given time. The next oddity to this is not just that part of the X chromosome has been silenced, but that it's being done through a non-coding sequence that is made up of RNA. And this is key. We're not talking about directly methylating the DNA, but rather using RNA to disable parts of the chromosome. This is useful in understanding possible causes or reasons why certain cancers are more common in males than females. And this is also the other key to this study. It was many different cancers from thousands of genomes of different cancer patients that had had their cancer sequenced. We know which gene, it's the inactive specific transcript or exist gene, that is responsible for making the RNA needed to silence that part of the X chromosome. While we are talking about a sex-specific related silencing process, it's not necessarily sex-cancer specific related, and so it could be possible that this is far more relevant to many different cancers than is initially obvious. Going from the strange reality of genetics and the ability to silence certain genes to the storage and freezing of embryos, and specifically the storage, freezing, and then thawing and implantation of 2 embryos from 1992. This means that they were put into storage more than 30 years ago and have now been carried to birth. The whole situation's somewhat bizarre in that the reason that this embryo has been implanted and has been the longest stored is simply because it was at the earliest donation time. As a consequence, the couple in this instance specifically selected the lowest numbers in order to have those embryos that were the oldest implanted and therefore give them an opportunity at life, which, whilst a very laudable and egalitarian action, is somewhat odd, as the longer an embryo has been frozen, the lower the survival rates are. Phenomena like this are not necessarily new, but the next piece of news related to reproductive technology is, specifically because it involves the treatment of a genetic disease before the child is even born. We're not talking here about genetic modification of an embryo or a similar sort of situation, such as what we reported several weeks ago with the donated egg exchanging the DNA in the egg with the mother's DNA and then fertilizing with the father's sperm. What the researchers did approximately 16 months ago was to treat a condition that's called Infantile-Onset Pompe disease. It's a relatively rare disease affecting less than 1 in 100,000. What it causes is low levels or complete lack of particular enzymes that are needed to produce glycogen. That's a way of storing sugar in the body. The researchers were able to substitute the lack of the necessary enzymes by artificially providing it to the developing embryo. This then allowed them to survive right through the development phase and into life. This would be the normal process anyway. The problem is the longer-term consequences. The lack of the enzyme during the fetal development phases causes muscle weakness and enlargement of the heart. This is what is nearly always fatal later in life for the developing child. While not exactly the same, it is very similar in some respects to enzyme substitution for those who have lactose intolerance. As with those who receive lactose enzyme substitution, the child in question was able to develop normally, shows no signs of heart abnormalities, and has hit all of their usual developmental milestones. Still on the topic of treatments, but shifting across to natural treatments. And natural is a complete misnomer with all of these products. They are all processed somehow, and there is no unnatural chemical. In fact, the term natural has no meaning in terms of marketing standardization or references. Or at least, none that isn't self-serving in terms of natural products are derived from nature, which is the most ridiculous way of defining natural that you can imagine. This is why it's rather funny that research coming out of Stanford University has found that skincare products sold at 3 retailers that were marketed as all natural turn out to contain a surprising number of allergens. 90% of the more than 1,600 products that were studied included many different kinds of allergens, and many of these were in the top 100 most common allergens known to cause dermatitis, otherwise known as eczema. The other concern is that dermatitis is about 3 times more common now than it was back in the mid-1990s. So the problem with all of these products having known allergens that cause dermatitis is not limited to a small population, but in fact a very large percentage of the overall population. When looking at the method for this, it makes sense, but it also makes the retailers and manufacturers look that much worse. The researchers were able to get a list of ingredients in all of these products from the websites of 3 big US retailers. They were then able to check this list of ingredients against the list of common ingredients that cause dermatitis. And here we are. Perhaps the soul-saving grace for the manufacturers and retailers is that many of the allergens that they identified are ubiquitous. Things like fragrances that really, if people have allergies to them, they would hopefully know by now and know to avoid them. There is, however, still a surprising number that are not so ubiquitous. And it does really put a very big nail in the coffin of what is natural is better for you. In a similar vein of thought, we go to Canada and a naturopath who has been suspended after really failing to care for their patient, if you even want to call them that. The patient says the naturopath failed to notice a tumour developing despite seeing them repeatedly. Unfortunately, their punishment doesn't really fit the nature of their action. They've been fined $5,000 and they were suspended for 16 days. That is big money and a serious implication for them, but not really. Doctors who have engaged in similar erroneous conduct will often lose their ability to practice. A naturopath gets a 16-day holiday and it costs them $5,000. While that's rather glib, there is good reason to say that the naturopath should have noticed. The person attended them thinking they had hemorrhoids, and it turns out that no, they had a tumour with their rectum. It's important to note that if you're going to pretend to be a medical professional, you should be acting like one. And in this case, by failing to notice a tumour developing like that, this could have been more than just them having to find another diagnosis that was accurate from an actual medical professional. Rather, it could have ended in someone's death, and that would be malpractice on top of incompetence. Shifting from a study of a naturopath screw-up to a study of a meta-analysis about acupuncture that is just as much of a screw-up. The problem with this particular article is that it is a meta-analysis, and as science-based medicine points out, it uses the garbage in, garbage out method, which fundamentally means that the meta-analyses took a lot of very low-quality, poorly conducted studies, aggregated their data, and then claimed that the results were more compelling because they were more studies. In theory, this would be fine if they were using better quality data, but because their data quality is terrible, you can't rely on the conclusions made. This is one reason why the press release associated with it that reads, "Acupuncture can relieve lower back and pelvic pain often experienced during pregnancy," is a nonsense quote. Imagine if we told you that tobacco use was perfectly safe and fine, and we cited a whole bunch of studies based on publications from tobacco companies. You would likely laugh us out as being stupid and easily duped. And this is similar to what happens when you use poor quality evidence for a meta-analysis. The poor quality evidence basically creates a bias, or otherwise undermines the veracity of the evidence you're trying to aggregate. The Science-Based Medicine blog goes into depth on just why and how this meta-analysis is flawed. And while we don't necessarily agree that every study must absolutely have every box ticked green, it is true that if you're going to be pulling studies across multiple different variables, you need to have comparisons between the same sort of studies. Which means if you're going to compare something with a randomized control group and blinding, you need to compare it with other randomized, controlled, and blinded groups. You can't mix different kinds of studies. This means that if they had done what they were trying to do, at least in theory, they might have been able to look at individual subsections of their data and reach conclusions, albeit much more weakly than they have claimed to. There's also the issue that some of the studies had incredibly high attrition rate, and this is a problem. The more attrition you have, the more unreliable your results are. Going from one blog on the lack of evidence for claims made to another blog that's related, the Neurologica blog, and an interesting article on artificial muscles. The idea of an artificial muscle is not necessarily new. We have effectively been using something similar in the form of springs for centuries now, but when we're looking at an actual muscle, something that can be used as, say for example, a prosthetic in a human, we are a long way away from that. Actuators, however, are at least a modest compromise when we talk about something like a robot, and this is where trying to find a way to simulate the biological process of a muscle contracting and relaxing becomes very hard. The Neurologica blog goes into the details of just how difficult it is going to be to create something like an actuator for a robot that has similar, if not the same functionality as a human muscle, or for that matter any other biological muscle would have. The biggest flaw they point out very early on is that it remains a challenge to realize both intrinsic muscle-like force velocity and force length properties in one single actuator simultaneously. In other words, having something that can moderate its strength and be able to apply more force as it needs to. If you have an interest in either prostheses or robotics, it is entirely possible that this article may be very interesting for you to read through to get a better understanding of what the barriers are to the ability to create a muscle, at least synthetically or prosthetically. Going from muscles to food, but also still muscle related in terms of the truth about the paleo diet. The paleo diet basically tells you to remove any kind of carbohydrate food from your diet. This is where you get most of your glucose from, and instead you are to substitute it with protein-rich food. In theory, this is not ideal, but it is entirely functional. If you are looking at evolutionary situations, you'll find that food that was high in stuff like fat and protein was favored where it could be easily consumed because it's high in calories. But as we moved away from hunter-gatherer societies, we began to rely more on things that were rich in carbohydrates, as they could be stored and provided that long-term energy. Today, the paleo diet, or variations thereof, are really only used amongst those who are practicing the dietary fad, or those who are prone to epilepsy and seizures, where it has been found to have some benefit. The whole reason the paleo diet seems to have become quite fashionable, let's say, is that there's an argument that we used to be healthier, that our ancient ancestors ate a better diet and that this was better for them. People have then tried to recreate this, hence the paleo diet and its name, Paleo. This is where digging up archaeological remains from long, long ago, as in when we were contemporaries with Neanderthals, evidence is showing that these people could perhaps be incredibly wrong. These ancient remains are indicators that it is entirely probable that when we were hunter-gatherers, we were still adding things like herbs and spices to our food to alter the flavor. And that, more importantly, that not only were we adding things to make them more flavorful, but that it is possible that we didn't have anywhere near as high a protein intake as the paleo diet would have you think we did. The research is very tenuous, but it does indicate that there was some sort of carbohydrate food found in the archaeological remains. This, they say, is some sort of bread, batter, or a porridge of some description. Either way, it's derived from some sort of grain. This is also backed up by the way they've conducted their analysis, which was largely done using a scanning electron microscope, which let them see the details of plant cells. However, this is all done with what is pretty much burnt remains. This is at least decent evidence, and very strong evidence when considered in the context of the other available literature, that no, humans weren't relying exclusively on meat, and that the paleo diet as it is now, probably not that good indicator of what we were like, and certainly not a good justification for being healthier. The final news we have for you this week regards a alternative means of producing rare earth magnets. Rare earth magnets are basically used in every piece of advanced technology today, whether it is something as simple as a solar panel, through to the supercomputer in your pocket in the form of a mobile phone. All of these things need rare earth magnets to be able to work. The problem is, there aren't that many places in the world that process rare earth magnets, and it's pretty much exclusively China now. The reason for this is the environmental impact of refining them. We are currently trying to find better ways to be able to do this, so therefore less environmental impact. But one means would be to make them completely and exclusively from a synthetic process. And this is where a University of Cambridge research team has come into play. They've been able to remove the millions and millions of years needed to turn a precursor to rare earth magnets into rare earth magnets. The attempt to make what is called tetranonite is largely impractical at the moment for mass production, but it does demonstrate that there is a means of turning it into a commercially feasible product that removes the need to extract them from the ground and process them in a very environmentally destructive method. The other caveat to this is that while they're able to produce something that does function, they're not yet sure if it is viable for high-performance magnets, which is what you'll need for the more advanced technological applications. However, reducing the need for lower technological applications could have significant benefits both from a production point of view and an environmental point of view. That's all the news we have for you this week. Thank you for watching. If you have found it interesting, consider liking, sharing, and subscribing. Please post any comments, questions, or suggestions you have below.